be looking at reading data tables and graphs. Take a look at these first two examples. On first glance, they look like very different graphs. However, if you take a look and use some of these skills I'm going to be teaching you, you'll notice that they are in fact the same graph. Over here, you see this green one starts at 80,000. Look at this one over here, also starts at 80,000. The orange one is showing that goes to 82. Over here, it's about 82. So first glance, you got to take a look at what's different than about these two graphs. Look at the starting point. This graph goes all the way down to 0, whereas this one begins at about 79,000. One thing to take note of when you're reading a table is to make sure that you understand your intervals. What are they going up by? Different interval spacing will create very different looks for your graphs and what you're looking at. Next up, take a look at data tables. When you read a data table, there's a couple of things you need to take into account. For example, what are they asking? What's the information showing? And you can read that off of the title, what you should have on every single table that you create. In this one, what sport do you play? Here are the results. Over here, the E. coli occurrences at St. Joseph, and those are written in percents. If I were to graph these, they're going to set up very similar, in fact, almost look identical. Right here, I have the number of people. Over here, percentage of cases. Both graphs have a title, and both of them have your label on the x-axis. Now, however, this guy is going to end up being a bar graph. This one will end up being a line graph. Let's take a look at why. A bar graph is going to be something where you have separate categories. Let's talk about that. A separate category would be soccer and tennis. Soccer and tennis, there's no reason to connect those two. Those are individual categories that can stand on their own. Remember, in a bar graph, to separate the bars, I'll talk about that on the next slide. A line graph, then, is going to be your most common one that you see over time. So because this one was being represented in years over time, a line graph would be the appropriate graph for that table. A common mistake is a bar graph versus histogram. Be aware when you are graphing, the bar graph then specifically has separate categories again. Red, orange, yellow, purple. Each one stands alone. There's no flowing into one to another. Over here, the results of an exam. Take a look. This is a histogram. The categories are grouped. So between 0 to 10, the number of students who scored that much are put into a group. And so they essentially flow together. So keep a look when you're creating your bar graph that you are not mistakenly creating a histogram where the bars are touching. Finally, a line graph. When you have a line graph, there's going to be predictions that are going to be made, and I'm going to refer to my video here at Virtual Nerd. If you haven't checked out this site, it's a great site to use.
Use the given graph to predict the cost of the new gadget in year 6. Well, here we've been given a graph. So let's go ahead and start things off by taking a look at it. That way we can figure out what we've been given and what we're looking for. First off, let's take a look at the title, Cost of New Gadget. So here we're looking at the cost of a new gadget. On this axis, we have the cost in dollars. So that's the cost of that new gadget. And on this axis, we have individual years. Now, we have line segments that are connected together. This is a line graph. We are looking at the cost of this new gadget over time. If we take a look at year 1, we can see the cost of that new gadget was a little over $1,200. Then in year 2, that price dropped a little. Then in year 3, it dropped a little more, then a little more, and a little more. Now, we're trying to find the cost in year 6. But notice, our graph does not extend out that far. So how are we going to figure out that cost? Well, what we can do is make a prediction based on what we already see here. So we can look at the trends that we have and extend them out. That way, we can make a prediction about what the cost might be in year 6 and get a pretty good idea. Now, we could do this a couple of different ways. First, we could just take this last line segment between years 4 and 5 and just extend that out. So just looking at this short-term trend of what's been happening over the last year or so. So if we extend out that line, we can see that it would go right here. In year 6, that cost would be about $200 if we would just extend out this last line segment. But what if we want to look at the overall trend? What's been going on this entire time? Well, we can do that too. We can take the point from year 1 and the point from year 5 and connect those together in a line. Just like this. Then to make the prediction, we can continue that line through year 6. Well, year 6 would be right here. And we can see that cost would be about $300. So now we've actually made a couple predictions. And here, things may not be exact. Again, we're making a prediction based on what we see. So let's go ahead and put this together and make a prediction about the cost of this new gadget in year 6. Well, based on what we've seen, if we just look at the short-term trend and extend out this last line segment, we get a cost of about $200. But if we take a look over this whole period of time, connecting the point from year 1 with the point from year 5, and then extending out that line, we get a cost of about $300. So, based on what we've seen here, it makes sense to say that this new gadget should cost around $200 to $300 in year 6. So now, we have used this line graph in order to predict the cost of this new gadget in year 6. Based on the line graph we were given, we said that the cost of this new gadget should be around $200 to $300 in year 6.